Hi, my name is Camila,
Hi, my name is Carla.
and I'm going to explain a differentiation problem about finding derivatives by definition.
And I'm going to explain a problem of limits at infinity.
Okay, so I'm going to explain a problem about differentiation, and this is problem number 53, and it is f of x equals 3x squared plus 4x minus 1. So according to the instructions, the first step we need to follow is to rewrite this function. Okay, now for our second step, we need to rewrite this function, but substitute x plus delta of x in every x we have in the equation. Okay, so for our third step, we need to substitute these two equations into our formula and write everything over delta of x. Okay, now as you can see, we changed the signs of the last digits because this sign over here, this minus sign, affects all of the equation. So for the following step, we need to distribute everything, and we need to start by this binomial squared. So according to the formulas, this binomial squared is expanded in this way. Okay, for our following step, we will need to use distributive property to multiply these 3 for every factor inside this parenthesis. Okay, now that we have already expanded everything, we will need to cancel all of the common terms in the denominator. So then we will rewrite this again. Okay, for our next step, we will need to factor out a delta x out of this equation. Okay, now that we have our equation, we will be able to cancel both of these common terms, which are delta of x. So now we will rewrite it again. Okay, since now this is the most simple way we can have this equation, we will substitute 0 in every delta of x that we have in our equation. Now we will solve this equation, and our final result will be the following. After we graphed the function on Desmos, we could notice that the vertex was on negative 2/3, negative 7/3, and the axis of symmetry was at negative 2/3. The graph is facing upwards since number 3 is positive, and we could also see that it has a horizontal asymptote in around negative 2.4.
So we're going to start to solve the problem of limits at infinity. It's number 13 overlap. So the first step is looking for the x with the biggest exponent in the denominator. In this case, it's x cubed. So we're going to divide the whole equation by x cubed. So we have to rewrite this every single time. Okay, so the next step is simplify as much as we can. So we're going to cancel our x's and yeah. Okay, now this is simplified and we are going to substitute with infinity. Okay, so now a basic rule is that everything divided by infinite will be equal to 0. So now we have to simplify again. Okay, so you might think that this is our final answer, but two basic rules of limits at infinity is that when we get 1 over 0, the answer will be does not exist, and if we get 0 over 1, the answer will be 0. So our final answer will be 0.
The following function is not continuous and has vertical asymptotes at x equals negative square root of 5, x equals 0, and x equals square root of 5. It has a horizontal asymptote at y equals 0 and no oblique asymptote.